Good AI morning, Islanders. Today, this broke college kid is going to be using the power of decision tree classification to pick out holiday presents on Amazon. So sit back, relax with your favorite snack, and let's get started, y'all. Happy holiday, Islanders. I hope you all are just having another wonderful day in paradise. For those of you brand new to the community, hello and welcome. My name is William McKeon, and the Islander robotics community is all about making artificial intelligence accessible by using Python to learn applications of artificial intelligence through demonstration. That may sound intimidating to some of you. Don't worry. Just keep in mind that I taught myself everything y'all see on this channel during my struggle as an electrical engineering major before I decided to switch majors to the dark side of computer science. So with all that being said, why don't we start creating one awesome decision tree model. All right, so in order for us to be able to make this really awesome model, we're going to be needing a few Python packages. The first one is going to be the pandas Python package, of course. I think that's kind of an icon of this class, well, not of this class, of this channel, as well as Islanders. Islanders is the brand new community Python package where it has an integration of IR data clean, which is what we've been working on, as well as a few other stuff that we're going to be adding as the channel continues to grow. The next thing we're going to be using is a couple of things from sklearn. We're going to be using the decision tree classifier, which is how we're going to be able to build this decision tree to make predictions on which products I should buy for my loved ones for the holidays. And the other one is going to be train test split, and train test split is really what the main bulk of today's video is going to be. And then the last thing is going to be NumPy. More on why we need all this stuff as this video continues on, but we're going to be getting our data set from the IR data set. Now, IR is the alias for Islanders. Within the Islanders Python package, our community's Python package, we're going to be having several different data sets that we will be working on as this channel grows. In today's circumstance, we're going to be working with the Amazon electronics data set. This is a data set I created by just going on Amazon and manually typing in all the information. It's really a data set of 100 electronics that are all listed over on Amazon, and we're going to set that equal to gifts. Once we have run this line, then we're going to be checking out what's going on underneath the hood of our data set. Now, real quick, before we actually check that out, I do want to mention there are a pip command as well as a conda command down in the description bar down below so that you can install the community's Python package Islanders on your local system. Now, the very first method we're going to be using is the head method, and let's just see what goes on. So gifts dot head. Once we check this out, we can see there are about 1, 2, 3, 4, 5, 6 columns, one attribute column that's going to be an object column. So we don't have to do anything with this price range. It's really going to be making sure that there's no missing values within this column, as well as we're going to be having to do some special stuff to everything else. Like names is going to have some sort of encoded data. Well, it's gonna have to have its data encoded in some way, and I have a couple of ideas on how to do that, as well as the rest should be what looks like numbers. We can make sure that all these columns are numbers is just by simply saying gifts.info. Oh, bada bing, bada boom, run that, and we can see that there are no missing values, as well as the two columns that we mentioned that were object columns are object columns, and our attribute column, or our Y column, if you want to call it that column, it has no missing values. And the last thing we have to do for the data prep is actually encode the column name. We're going to be doing this in a very unique way, and that is we're going to say name equals a list comprehension of I for I in gifts.name. All right. What we're going to be doing is, since each individual row of name has its own unique value, we're just going to turn that into a list and then drop that column, because rankings can be essentially our product ID for each one of those products. So the way that we're going to drop name is actually just say gifts dot drop, and we're going to say columns equals name comma in place, because we actually just want to make sure that gifts automatically gets dropped. If we were not to add in place, as soon as we ran this line, name would actually get re-added back, and we don't want that. So we're just going to delete this because it's all caps, true, and then run this code. Oh, I put an S, my bad. Run that, and the next thing we're going to want to do is define our features columns, or our X columns, as well as our attribute columns, also known as our Y columns. The way we're going to be doing that is turning those, we're going to convert them from a pandas data frame to a NumPy array by simply saying inside of the cell gifts underscore x equals mp dot array. And we're going to say gifts dot ilock, and we're going to, within ilock, we're going to be creating some brackets. These brackets is going to first have an input of colon, meaning we want everything within that one column, every single one of those rows, and the columns that we want to be included right now are going to be all the columns except for the last one. So we're going to do colon -1. Once we've done that, we just say dot values, and we can continue on to specifying our attribute columns, which is going to be gifts underscore y is going to equal our mp dot array gifts dot ilock, except with this ilock, we're not going to be doing colon -1. We're just going to be doing -1 dot values. And then the next thing we're going to want to do, and the whole reason why we did this, was we're going to be splitting our data set into training data set as well, training data and test data. This is really important when you're dealing with models like a decision tree classification, which is a supervised learning algorithm. You have to do this in order to be able to train the data. So the way that we're going to do this is just say x train comma x test. Now these are going to be the variables that define our training x values and our test value, well, our test x values. The next thing we want to do is specify our y values for the same exact stuff, and we're going to say y comma y underscore train comma y test, and we're going to set this equal to sklearns train test split method. So we're going to say train test split, and within train test split we're going to specify our x values and our y values, which is just gifts x and gifts y. The next thing we're going to do is really important because of so many different reasons, but it's going to be the training size of our training data set. So the reason why this is super important is because if you make this number too big, our data set, well, our model is going to overfit the data. If we make this too small, it's then going to underfit our data, neither of which we want. It's kind of like the story of Goldilocks and the Three Bears. We want to get this number just right, and the reason being is because this is defining the percentage of our data set that's going to be turned into training data. And the way that we specify this is training size equals 0.2. All right. Now what we're telling train test split is to turn our 20% of our data set into training data. Now I can't give you an absolute number that will work perfectly for every model because each data set as well as each model is going to have its own unique special value. In reality, 0.2, I am not 100% sure is the perfect number for this data set as well. But once we do that, we're going to run this line, and now we're going to be able to actually create our decision tree. And the way that we're going to do this is just by saying dt equals decision tree classifier. There are input arguments you can put within these brackets. We'll get more into this on a later video. But once we've done that, we're going to run this line. And the next thing we're going to want to do is actually train our data to the model. So we're going to say dt dot fit. All right. And then within the fit method, we're going to specify our training value, which is going to be x train and y train. Once we've done that, we can now start making some predictions, and we're going to store all the predictions to a variable called y pred. All right, and we're going to set this equal to dt dot predict, and the value that we're going to pass into the predict method is actually going to be the test values, our x test values. So let me just correct this, and we're going to say x underscore test. We're going to run that, and now we can actually start doing some really cool stuff, like having the decision tree predict what presents I should be getting my loved one for the holidays. Now, the way that a decision tree classifier works is like like a binary tree classifier, except we're going to be having multiple different classes for this classification. And in our case, I want to be looking at presents from 25 to 50. So that is how we got this for loop set up, where we're going to be having an empty list called options. There we're going to be going into a for loop that's going to be going for the length of our y pred. Now, what we're going to be looking for is if y pred at index I is equal to 25 to 50, we're going to be adding that to our gifts list, allowing us to be able to see what presents I should be getting my loved ones for the holiday season. Now, alrighty, Islanders, so I have my holiday shopping list, but how do I know how accurate this model is? Well, what we're going to be doing next is actually evaluating the accuracy of this model. First off, by adding the code we got over here inside this cell. Now, what's going on within this cell is basically everything we just went over in today's video, but there are two differences. The first difference is we're actually going to be encoding our price range. Yes, I know earlier on in this video I said we don't have to mess around with the price range column. And the reason why we're messing around with this price range column now and using ordinal encoder to encode that column is because we want to call upon the score method within the decision tree classifier. Now, the score method within the decision tree classifier does not work if you're trying to pass in a column that is filled with object values. And because of that, that's why we had to actually encode that column. So when we run this one line, we're going to see an accuracy of 0.925. Now, that is relatively good actually in retrospect because this score is out of 1. So that's saying our model is 92% accurate. I gotta tell you all something real quick. For those of you that are following along at home, going line by line with the code, if you got a different score for the score, do not worry. The reason why is because, and if you go ahead and run that one cell over again, you're gonna notice a different score. And the reason is because test train split, each time it runs, it shuffles up your data set and therefore then splits up your data set into the retrospects of each one of those testing values and those training values. So each time it shuffles it up, the accuracy of your model is going to vary. So if you got a different score, don't worry about it. As well as there are a lot more ways to actually make this decision tree more accurate. And we'll get into this in a future video. So go ahead and hit that subscribe button as well as that bell icon if you have not yet done so you can get notified when I post that decision tree video. Thank you all so much for watching to this point. And if you want to learn more about artificial intelligence, go ahead and check out the videos popping up on the screen right now. As always, don't forget to laugh when you have a programmer's headache. It helps with the pain. I'll see you all in the next video. Bye.